C3h, allotropes of carbon and nanochemistry. So carbon, the element, can be found in three stages, either as diamond, graphite or in fullerenes. Starting with diamond, diamond is a macromolecular giant covalent structure of carbon where each carbon has 4 covalent bonds attached to other carbons, which gives it a huge lattice, which makes it very, very strong, one of the hardest natural substances, and it has an extremely high melting temperature. This leaves diamonds useful for jewellery, but also for cutting equipment. Because of how hard it is, it can cut through most other substances. Graphite, another form of carbon, is where carbons only have 3 bonds and they form layers, and these layers have got this extra bond that's not being used, so we have delocalized electrons above and below each plane. This allows it to conduct electricity because of the electrons freely moving between layers. Graphite is the centre of your pencil rather than lead. It's actually graphite, which is again the layers sliding off each other as you're writing on paper. Because of the layers sliding, it can also be used as lubricants. And finally, it's used as electrodes in electrolysis because it conducts electricity, has a very high melting temperature, and as a byproduct, when it reacts, it usually escapes carbon dioxide. Finally, carbon can be found as fullerenes, which is C60. 60 carbon atoms formed into pretty much a football shape, but it's a nanoparticle, meaning its length is between 1 and 100 nanometers. These have been used in development of drugs because you can place certain items inside the cages for delivery to different parts of the body, but because of the huge surface area they have also been used in development of catalysts.